Today we don't use the projector. You can download the slide from the uLearn, right? Have you downloaded the slide? Okay. In the last week, I think still section one. Some of you still haven't watched the recorded video, right? Okay, please watch the recorded video, okay, and complete the exercise submitted by this week. Okay, by this week. Okay, so today we will continue with the how to solve, how to categorize first, how to categorize a first order differential equation. Okay, first order differential equation, it must be in the form of something like this. By yes. Okay, first order. Okay, it is first order because of this first order derivative. So there are two types. Okay, in this course you will learn two types of this first order differential equation. Okay, the first one is separable. Okay, and the second one is linear. So we start from the separable. Okay, actually there are more than two types. Okay, there are more than two types, but in this course we will just look at that two. Okay, separable and linear. Okay, so for separable differential equation, when we want to identify whether it is a separable or not separable differential equation, first, what you need to do is you write out your dy dx. Okay, write out your dy dx, and you will get a function in xy. Okay, we get a function in xy. So from the function in xy, we try to separate them, okay, into a function in x multiplied to a function in y. Okay, that means one function in x multiplied to another function in y. If you are able to separate the function into this form, that means it is separable. Okay, otherwise it is not separable. I give one simple example. Let's say your dy dx is x plus y. Is it separable?
Yes.
Is it separable? Can you put this into this form?
Yes.
A function in x multiplied to a function in y. No, definitely no. So this is not separable. Okay, this is not separable. So we will just write this cannot be u x b y. Okay, not separable. Separable. Now I give another example. Let's say dy dx is 3xy. 3xy. Is it separable?
Yes. Yeah.
Yes, because you can have 3x times y. That means function in x only multiplied to another function in y only. So this is separable. Okay. So to identify a first order differential equation, whether it is separable or not separable, first we will display, okay, we will find the dy dx first. Because not all the differential equation is given in this form. Okay, it can be 2x dy dx plus 3y equals to 1. It can be something like this. Then you have to express what is your dy dx. Okay, what is your dy dx? So this one, your dy dx will be
1 minus 3y divided by 6.
1 minus 3y over 2x, right? Move this to the right, you have 1 minus 3y. And move the 2x to the right, you have over 2x. So is this separable?
Yes. Yeah.
Yeah. Okay, this one can be 1 over 2x and 1 minus 3y. Okay. So this is separable differential equation. Okay, only for first order. Okay, now I'll show you one example. If it is separable, then how should we solve it? Okay, 2 minus y dy dx plus xy equals to 0. Okay, so now we want to identify whether it is separable or not. So we want the dy dx. Move this to the right. Okay, dy dx. So you get a negative xy. So your dy dx will be negative xy over 2 minus 1. Is it separable?
No.
Yes or no?
Yeah. Yeah.
Yes. Negative x and y over 2 minus y, right? Function in x only multiplied to another function in y only. Okay, so since this is separable, okay, next what we do, we move all the y to the left, move all the x to the right, so that all y on the left, all x on the all y on the left, all x on the right. So this one move, then you will get this one. When you move to the left, you have 2 over y, 2 minus y over y, and then y. And on the right, you have negative x. If the x goes up, if the dy and dx, you have this integral. Okay, you have the integral sign for this dx and also the dy. Meaning that we are integrating this function with respect to y and this with respect to x. We are integrating both sides. Okay. So how to integrate the left-hand side? This one, how to integrate this? We separate this two. right? 2 over y minus 1. This is, okay, take out the negative. So we can start to integrate. So integration of 2 over y with respect to y, you get a log 2 log y. 2 log y. 1 over y, when you are integrating over y with respect to y, you get log y. Okay. Now you have 2, so 2 log y minus y. Okay, equals to negative plus c. Okay, suppose we have plus c on the both sides. This one, let's say this is plus c1. This one we give a plus c2. C1 and C2 are both constants. And at the end, we can move the C1 to the right and combine with the C2, and we get a new constant, right? So we just use one constant. Okay. Because we assume that the two constants combine together to get this C. Okay, then this is the answer. If you are able to simplify, then we simplify. But this one, since you have log y and it's y, okay, you just leave it. Okay, it's just form. Okay, any questions? I repeat, for separable differential equation, when we want to identify whether it is separable or not, we will express dy dx in terms of xy. Okay, so you just rearrange. We want only dy dx on the left. And after that, here you try to see whether you can separate that into one function in x multiplied with another function in y. If yes, then separable. Okay. If it is separable and we want to further solve it, okay, then all the function y you move to the left, all got to do with x, we move it to the right. With the dy, you have this. With the dx, you have this. So you just integrate both sides with respect to one is y, the other one is x. Then we get the final answer. Okay, so this is separable, first order separable differential equation. Okay, now I want you to try the exercise. Try the exercise. This is exercise 1.1. You refer to the notes, exercise 1.1. What's the x plus 1? Okay. Try to get the dy dx first. Okay, the question is identify whether it is separable. If yes, then solve the differential equation. Okay, if it is not separable, then we just leave it. Just give the symbol. If it is not, then you just give this. Then not separable. If yes, we just continue to solve it. Okay, try to get the dy dx first. Is it separable? Is it separable? No, this is not separable. Try number 2. Find some? Okay, good. Below this, given is what is your d1dx?
X over Y.
X over y. Okay, is x over y separable?
Yes.
Yes. Okay. Then we can solve by move the y to the left. Keep the x and move this dx to the right. Okay, this one we can simplify by multiplying the 2 to all of the terms. Multiply the 2, so you have y squared equals to x squared plus still a c. 2c is still a constant. Number 2.
Yeah.
Any questions?
因为你上车停的些那个火灯的话是一个直接上面那个放下来车掉，现在你的你要放那边去一个。
Okay, for exponential function, EA plus B is EA times EB. EA minus B is EA over EB. Okay, so this is separable. Then, when you move this E3y to the left, what do you get? When you move this E3y to the left, it will be 1 over E3y, right? 1 over E3y is E negative 3y. Okay, this negative means 1 over E3y. You got number 3. Okay, integration of exponential function. Then you differentiate this, you get a negative 3. Okay, this one you can simplify by. Okay. Move the negative 3 to the right hand side, so you have 3 over 2 plus 6. Still a c. Negative 3c still a constant. Okay, number 4, and start number 4. Is it separable?
Yes.
Yes. Okay, it is separable. Okay, then move all the y to the left, all the x to the right. Then you can start to integrate. Okay, how to integrate? What technique you use for this? Technique of integration. The technique of integrations that you have learned is integration by parts, where you can use tabular method. Integration by substitution. And you have learned this too, right? No? This one? Which technique? Which technique? By substitution, right? By substitution. Okay. Other than substitution, okay, this one, if you use substitution, that's when you let u to be 1 plus 5y. Then you are integrating 1 over u, right? 1 over u, and then we do not want dy. We find for du dy, where you get 5. That means we want dy, right? So du over 5 is dy, right? Dy goes up, 5 goes down. So your dy is du over 5. And next that you have 1 over 5, integration of 1 over u, you get ln u. So your u is ln 1 plus 5y plus c. So this is integration by substitution. You learned this is in EM1 last semester, right?
Yeah.
And you have written to me.
Yes.
Okay, other than substitution, I think I introduced the formula of this one as well, right? Did I? Whenever you see a function in a fraction form, you try this one first. Try this one first. What is this? integration of a fraction function where when you differentiate the denominator, you get the nominator. Then the answer, it will be ln denominator. So this one, okay, I give one example, one simple example for this one first. Okay, let's say you have 1 over 2 over x, 2x plus 1. 2, right? Okay, so according to this one, when we differentiate 2x plus 1, we get a 2, right? When we differentiate this 2x plus 1, we get a 2. So the answer will be ln 2x plus 1 plus c. Okay, what's happened if your question is something like this? When you are differentiating 2x plus 1, you should get a 2, but you have only 1. So what we do? We multiply a 2, but we divide the 2 outside because we can't change the question. This one, when you insert a 2 here, then you divide the 2 outside, meaning that we can cancel out the 2, and this is still the same as the previous, okay, the same as our original question. We don't change anything. Okay, when you multiply a constant inside, you divide that constant outside. Then now we do have the 2 that we want, right? When you differentiate this one, you get a 2 here. Okay, so the answer will be 1 over 2. This one, it gives you ln 2x plus 1. Right? So same goes to this. Same goes to this. When you are differentiating this, you get a 5. Okay, you get a 5. But we do not have 5 here. So you multiply a 5 here and you divide the 5 outside. Right? Then this one, you know what is the answer? Ln 1 plus 5y. Okay, this one, when you are differentiating this one, what do you get? What do you get when you differentiate 1 minus x squared? 2x. Negative 2x. Negative 2x. We need the negative 2. So we multiply the negative 2 inside and we divide the negative 2 outside. Okay, but this one, we can only manipulate on the constant. If you need an extra x inside, we can't multiply x and then divide x outside. No. We can only multiply a constant inside and divide the constant outside. Okay, then this will be 1 over 5 ln 1 plus 5y. Equals to negative half ln 1 minus x squared. Then you get the answer. Okay, this one actually we can further simplify because the answer that I gave in the slide is the simplest form. Error besok. This one you can further simplify by multiply the 5, move the 5 to the right. Okay, then because this is ln, this is also ln, we can combine. For a ln function, the constant in anything in front of the ln function, the coefficient function of the ln function, you can bring it inside and will be the power. A ln x is actually ln x power of a. Right? This is the character of the ln function. So this 5/2, you can bring it inside to be the power of this function. 1 plus 5y, okay, plus ln 1 minus x squared, power of 5/2. And then ln a plus ln v is ln av. Okay, ln a plus ln v is ln av, meaning that you have this 1 plus 5y, 1 minus x squared, power of 5/2. This one is equals to c. Okay, move, and then this is equals to c. Okay, then ln x equals to y. So what is your x? When ln x is y, what is your x? E to the power of y, right? Ln x equals to y. So equals to e to the power of c. C is a constant. So exponential to the power of constant is also a constant. That's why you see at a. This one equals to a. C is a constant. Exponential to the power of constant is also a constant. So if you find the exercise from an international reference book, normally they will give the answer in this form. Okay. The international reference book, normally they will give the answer in the simplest form. Yeah, I'm not sure, maybe some of you find the exercises from outside. Okay, any more questions for this question number 4? No? Okay, now we look at the next one, dy dx plus y squared. Equals to yex. Okay, number 5. Is it separable? Okay, the answer is no, not separable. Because your dy dx is yex minus y squared, where this cannot be separated into ux vy. So not separable. Okay, last one. This is it separable?
Yeah.
Okay. Yes, it is separable. Okay, separable. So we move y to the left. Okay, x to the right. So when you move this tangent y, you get a 1 over tangent y, right? Okay, what is tangent y? Sine over cos. What is 1 over sine over cos? Cos over sine. Okay. What is 1 over cos? 1 over cos is? 1 over cos. Secant. Secant x. Okay. So this one, how to integrate left hand side? We used the formula just now, right? When you differentiate sine y, you get a cos y. When you differentiate sine y, you get a cos y. So ln sine y. Okay, right hand side, secant x. Okay, secant x, if you want to integrate the secant x, actually the working is very, very long because you need to do the substitution. Okay, substitution using trigon. Okay, but because of the formula just now, okay, because of the formula just now, we can multiply the secant x with a function which is secant x plus tangent x. This is only applicable for the secant x and for the integration. We do not change anything. Okay, we don't change the question. We are multiplying this function to the secant x, where this can be cancelled out. So what's happened when your secant x multiply into this function? So secant squared x plus secant tangent over the secant x plus tangent x, right? Left hand side is ln sine y. Okay, then you have a negative. So what is this? use the formula just now. Differentiate secant x. What do you get? Differentiate secant x. You get a secant tangent. Secant tangent. When you differentiate this one, you get secant tangent. When you differentiate a tangent x, you get a secant square. Meaning that you are differentiating this one, then you get this one, right? So the answer is ln secant x plus tangent x. But C. Okay, then this one moved to the left. Then you have ln sine y plus ln this. Ln A plus ln B. Okay. Ln A plus ln B is ln AB. So ln, when you move to the right hand side, you get an e to the power of c. E to the power of c is 8. Okay, any questions? This is the shortcut way for you to integrate the secant x. Okay, questions? No? No, then I will move to the second category of the first order differential equation. Left hand side. Okay, next one, we look at the linear first order differential equation. So do you still remember how to identify whether the differential equation is linear or non-linear? How many criteria? Two. Is this linear? Is this linear? No. Okay, the first criteria, it will be, it should be this one, derivative, and also the dependent variable should be degree of 1. Degree of 1. This one is degree of 2. So this is non-linear. And the second criteria is the coefficient function of this y, okay, the dependent variable, and also the right-hand side function. It should be all in independent variable. Okay, so two criteria. So now, if the differential equation is linear, okay, the first order differential equation, if it is linear, then we will go through these 5 steps to solve it. Okay, the first step is you have to express the differential equation in this form, where the coefficient function of dy dx should be 1. It should be 1. So if you have, let's say 2, okay, 2 dy dx plus y equals to, let's say, x, okay, then your step 1, it will be 1 over 2 y equals to x over 2. The coefficient function should be 1. This is your step 1. Okay, this one should be 1. Okay, it must be dy dx from here. Okay, then step 2, identify the coefficient function of y, which is this one, plus px. If this is minus, this will be minus as well. Okay, So you are integrating the coefficient function of y with respect to x, okay, with respect to the independent variable. Okay. Then step 3, we will find for the integrating factor. Integrating factor is denoted by the rho. Okay, the rho is exponential function to the power of. This is what you obtain from step 2. Okay, so let's say your step 2, what you obtain is x. Then your step 3, it will be rho is e to the power of x. Okay, if what you get is 2 from step 2, then your step 3 will be rho equals to e to the power of this x. Then step 4, we will multiply this integrating factor to both sides of equation from step 1. Okay, that means we will multiply ex to this, and this. Okay, then step 5, we will differentiate both sides of the function. Okay, both sides of the function. Okay, now we look at one example. Okay, dy dx plus y. dy dx plus y equals to x squared. Okay, so this is your step 1 function, right? Your step 1, this one, dy dx plus y equals to x squared, because the coefficient function of dy dx is 1. This is what we want. Then step 2, you need to integrate 1. Okay, because the coefficient function of y is plus 1. Okay, so 1. So this one you get a x. Okay, x. Ignore the constant plus c. Okay, ignore the constant. Okay, step 3. Your integrating factor is exponential function to the power of x. Okay, step 4, we need to multiply this ex to both sides of this. Okay, so ex multiplied to this dy dx plus exy equals to x squared ex. Okay, this is your step 4. Then step 5, we need to integrate, not differentiate. This one should be integrate. Sorry, integrate, not differentiate. Okay, so step 5, we need to integrate this. Okay, this one, if you want to integrate this function, okay, there is a simpler way to combine these two. This can be expressed into this form, d over dx, where inside the bracket there is a integrating factor. Integrating factor times dependent variable. Okay, dependent variable is y. Okay, right hand side, no changes because we are simplifying these two terms into one term. Okay, even start to do the integration. Okay. Okay, this one I repeat. If you follow strictly step 1 up to step 4, your step 5, you can combine these two into one. Okay, d over the x is follow this one. If this is x, this will be x. Inside the bracket, this is the integrating factor, and this is the dependent variable. Okay, no matter this is plus or minus, we don't care. Okay, inside the bracket, you have integrating factor multiplied to the dependent variable. Okay, then this dx, we move to the right. Okay, to move to the right. Okay, because if you are integrating this one, okay, this is differentiation. When you are integrating this one, you get this back. Right? After you differentiate and then you integrate, you get this back, right? Okay, so in short, we just move the dx to the right. We are integrating this. Okay. After you integrate this, you get this. Then this one, you need to integrate. Okay. Then this one, how to integrate this? X squared EX. Tabular method. Tabular method. Polynomial with exponential. Polynomial with sine or cos. Or polynomial with, or exponential with cos or sine. Tabular method, right? Okay. Yeah, tabular method. X squared EX. Differentiate this until you get 0. Do X to 0. Integrate this 3 times. Okay, you get the same function. Start with plus. Alternating sign, plus minus, plus minus. Okay, so the answer for this is plus x squared is x minus 2x ex plus 2ex. Okay, then on the left, no changes. Okay, then we want the solution in y. Okay, y in terms of x. Okay, so what is your y?
X squared minus X.
Okay, you can cancel out the x squared, right? Minus 2x, cancel out the ex. This one, sorry, I forgot about plus. Okay, it should have a plus c here. Okay, then plus 2. Cancel out the ex. And this one, c e negative x. So this is the answer. Okay, so I repeat. Once you have identified that as a first order linear differential equation and you want to solve it, you have to follow 5 steps. Step 1, make sure the coefficient function of dy dx is 1. This is your step 1 differential equation. Step 2, identify the coefficient function of the dependent variable. Okay, then we are integrating it with respect to x. Okay, step 3, we want to get the integrating factor. Okay, the integrating factor is denoted by rho. Rho is an exponential function to the power of step 2. Then multiply this integrating factor to step 1. You get this. Okay, then before you integrate, you combine these two by using this way, d over dx in the bracket, integrating factor multiplied to the dependent variable. Then you move the dx to the right, integrate right-hand side function with respect to x. Okay, this one, okay, after you move dx, it will be this one, okay, the one in the bracket. And finally, we just want the y. Any questions? Okay, this one, I show you. Okay, this one. If you differentiate this, you will get this back. Okay, if you differentiate this function, You may get this back. This is UV. Okay, UV. If you are differentiating UV, we use product rule. Product rule. Okay, so now let's say I copy EX. Copy EX, differentiate Y with respect to X. dy dx. Okay, plus now copy the Y, differentiate EX, you get EX. Right? You get this back. Okay, now is try to work out the exercises. Can I run this off? Okay, exercise 1.2. Okay, is it linear? No. If no, there must be a reason. Why no? Who give the answer no? There must be a reason. Okay, if you say no, okay, this is linear. Okay, this is linear because this is degree of 1. Y also degree of 1. And then the coefficient function, this is constant, this is constant, this is function in X. Okay, so the coefficient functions can be in X or constants. So this is linear. Okay. So step 1. Step 1, look at this. This is what we want. So this is our step 1 differential equation. Okay, step 2. We want to integrate. What is the coefficient function of dependent variable? -2. Here, -2. Okay, so what do you get? -2x. Okay, step 3. Integrating factor. Integrating factor is an exponential function to the power of step 2. Okay, to the power of what you obtain from step 2. Step 4. Multiply the integrating factor to step 1. Okay, try to work it out. Notice my independence? Multiply this integrating factor to step 1. Okay, step 5. Inside the bracket, you should have
negative of x times 1.
integrating factor e negative 2x times
Y.
y. Okay, equals to the right hand side function. And move the dx to the right. Okay, then integrate this using tabular method. Tabular polynomial with exponential. Okay, tabular method. Yeah, put the tabular table here. X plus 1. E negative 2x. Any questions? Okay, and lastly, we want to divides divides the e negative x to the right. Cancel out the e negative x. Cancel out the e negative x. And then this will be c e to x. Okay, any questions? Any questions? One over. This one. Okay, any more questions? Okay, now then next. Equation just now is dy dx minus 2y. So you look at the dependent variable, find for the coefficient function. Now we are integrating the coefficient function of the dependent variable. Okay, number 2. Is that linear? Yes. Derivative, degree of 1. Dependent variable, degree of 1. And the coefficient function of these two are constants, and this is in x. Okay. So step 1, you need to rearrange your differential equation in such a way that the derivative and also dependent variable stay on the left. Okay. So dy dx minus y equals to negative e to x. Okay, on step 1 equation, okay, it must be the derivative and dependent variable stays on the left. The one without dependent variable, we move it to the right. Okay, step 2, we are integrating. What is the coefficient function of y?
Negative
Negative 1. So you get a negative x. Step 3, your integrating factor is an exponential function to cover up step 2. Or multiply the integrating factor into step 1. So for step 5, what do you have in the bracket?
E negative.
The integrating factor E negative x times y. This one you have negative combined into 1e, so the new power is
X.
x. Total up, sum up these two. You get x. Okay. When you eliminate the E negative x, this one, what is the new power?
2x.
2x. 1 C E
X.
x. This is 1 over EX. Right? 1 over EX. So bring up, you get this. Okay. Bring it up, you get this. Bring it up, you get this. Okay, any questions? Yeah. Okay, number 3. Is it linear? Why? Linear due to the term of dy dx squared. This is degree of 2. Okay, the rest, no issue. Okay, only this term caused the non-linear. Okay. Since it is non-linear, so we don't have to solve it. Because according to the question, okay, the question of this exercise is determine whether or not each of the following equations is linear. If yes, solve the differential equation. Okay, done. Okay, number 4. Is it linear? Yes or no? The answer is no. Non-linear due to the term of which one?
Square.
Square. Huh? Which term?
Coefficient of y. It must be.
Derivative power of 1, okay. Y power of 1, okay. Second criteria, the coefficient function must be in the independent variable. So this one in x, okay. This is not in x. Okay, for those who haven't watched the recorded video, please settle it by this way. The quiz 1, it involves big one topics. Okay. Done. And number 5. The linear. Yes, it is linear. Okay, but you can only see after you rearrange this because the right hand side is 0. Okay, when you rearrange this, 1 over y dy dx equals to negative x. Bring up the y, dy dx equals to negative xy. Bring this back, dy dx plus xy equals to 0. So this is linear. Why the question number 3 and 4, they are still non-linear? Because there is no way for us to rearrange until we get it linear. Okay, no matter how you try for question number 4 and 5 just now. Okay, number 4 is this one. Okay, because of the square. Okay, because of the square, confirm we can't make it linear. If you use the square root, this will be square root of 5, which is not acceptable. And number 4 just now is 1 minus x squared dy dx plus 1 minus ey y equals to 0. Okay, even though this is 0, if you move this to the right, negative 1 equals to negative 1 minus ey y. no matter how you rearrange, you still can't get the linear. Okay, the linear differential equation. So non-linear. Okay, this one, after you rearrange, because of the right hand side is 0. When the right hand side is 0, it might be possible. It might be possible. Okay. To be rearranged until you get linear form. Okay, possible. So you have to try. When you see right hand side 0, you have to try. Or you can try to multiply all the terms with y. When you multiply all the terms with y, you get dy dx plus xy equals to 0. Okay, that's mean when you try, okay, okay, you can straight away multiply the terms. Okay, just do whatever you can. If you still fail to get the linear terms, then it is non-linear. So for this one, the step 1 function is dy dx plus xy equals to 0. Okay. When you multiply y, it will be much faster. Multiply y, multiply y, multiply y. Okay, then step 2. You are integrating
X.
x. Okay, coefficient function of y, which is plus x. So x, when you integrate, you get x squared over 2. Okay, step 3. Step 3 is integrating factor. So it is an exponential function to the power of step 2 function. And step 4, we multiply the integrating factor to the step 1 equation. Okay. What do you have in the bracket? X squared over 2 times y. Okay, times y. So right hand side is 0. Integrating 0, you get C, a constant. Okay, a constant. So y is C e negative x squared over 2. Okay, so we have done the topics for week 1. Okay, week 1. Okay. So in the next class, we will start week 2 topics. Any more questions before we end the class?
Step 5.
No, for step 5, you just use the integrating factor to find the independent of
Whatever it's on,
yeah, just ignore because when you do the reverse, when you differentiate this one, you will get this back.